Hello everyone, welcome back. Okay, so what we have right here is a channel section and subjected to a vertical shear force of 31 kilonewtons. What we want to know is the horizontal shear stress at point A and the vertical shear stress at point B. Now why is one horizontal, one vertical? It's simply because this is a vertical section and that is a horizontal section. Now, with that in mind, I let you go off and do exactly what it says to do. Calculate that horizontal shear stress and the vertical shear stress at point P. So 3, 2, 1. And hopefully you're back. Maybe you went and got pizza and you forgot and you left the video going. Either way, I'm okay with that. Just save me a slice. But if not, if you went and did the problem and you came back and you did well or did terrible, either way, I'm here to help. So let's jump right into this. Okay. Now, first off, we have to calculate the centroid because this is not it's symmetric, but not in the y direction. We're going to need that. Now, you've done this a whole bunch, so I'm not going to focus on it very much. Just remember the table is your friend, okay? Don't forget tables. Tables are amazing. Okay. Also, moment of inertia. Well, there's 3 sections, the left, the bottom, and the right. But I think this is actually an absolute terrible way of having done this. The much simpler method would have been to simply say that there is a big rectangle and then a negative rectangle. I would have preferred to do that way. That's only 2 sections and it would make it a lot simpler. But you do it how you know it, okay? You don't have to do it my way. You can always do it your way. Have it your way. Okay, with that in mind, you get the moment of inertia, we've got the centroid, we move on from there. Now, if you're having trouble with moment of inertia and centroids, you need to stop right now. You need to contact me and we will work through that together. Otherwise, let's keep on going into the hard stuff. So first we're at point A. We're going to have to figure out what the shear stress A is, and so we need the first moment of area for point A. And this time we're doing it a little bit smarter. You can see that right there, we are starting at this dividing line and moving straight over. We're starting at that dividing line and moving over. So with that, we can calculate our value of Q. It's not that difficult. Also, since we've done it this way, we're not going to divide our shear force by 2. Our first moment of area is already divided. Last time we didn't divide it, we just divided it later. This time we're not going to need to do that. So our first moment of area is simply going to be the area of this section times its distance in the y direction from the centroid. So we do that right here. We have the area. This is the thickness. This is its length. And this is the distance to the centroids. And we plug that into our equation. Easy peasy, not really too much to it. Thickness right here, moment of inertia, first moment of area, and finally our shear force that was given. Okay. Now let's go to point B. Now you could have started from the center if you want to. You can do that, but you don't have to. You don't have to. So instead, you're going to start from this point right here. So we're going to start at that z-axis and then extend upward. And so we need to get, luckily for us, point B is right on that centroid line. Thank goodness. Whew. Don't have to worry about this too much. And so we can figure out the height pretty easily. It's going to be 57.941. That's just the height right here minus our distance to the centroid in the y direction. And then with that distance, we're going to divide that by 2 to simply get our distance between the centroids. And once again, we just plug everything in, being very careful to use the correct thickness. So remember last time, it was 16 millimeters. That was for the bottom. For the sides, it is 12. Little details like that are what sink you in these kind of problems. And we're done. The biggest difference between this example, I think this is it. Yes, we're going on to a group problem next. Whoop. The biggest difference between these problem and the last is simply that we didn't have to divide that Q by 2, or the shear force by 2, because we started from a point where it was 0 and moved to that point. Or we went from the top where it's also 0 and moved to that point. Either way, we just went in one direction. We only did half of it by doing the whole thing. So that's it for this time. thank you for listening. Hopefully that first motive area is beginning to click now as we see more and more examples be done. And I appreciate your attention. Have a wonderful day. Bye-bye.